Dear viewers, today in this video we will discuss molecular view of the solution process just to understand dissolution process or how solutions are formed. Basically, we know that molecules are held together by intermolecular force of attraction or intermolecular force of interactions. Mainly factors which influence on dissolution process are basically disruption of molecular bond, which you can say disordering of ordered solute or the solvent molecules, disruption in the solute or solvent molecules. Number 2 is the enthalpy change. Point 1, which is the disruption in the molecular bond. Under this condition, particles of solute disperse throughout the solvent, or we can say solute particles occupy the space given by the solvent molecules. There are 3 types of interactions on the basis of which solute particle replace solvent molecule, that is solvent-solvent interaction, solute-solute interaction, or the solute-solvent interaction. Particles replace the solvent molecules basically depending on these 3 types of interactions. For clear understanding, we consider an imaginary situation of solution process or the dissolution process in these 3 steps. Although it's clear solution process is not happening independently in these 3 steps, which is step 1, 2 or 3, which we are going to mention within this video. That is totally or purely an imaginary situation, but happening at the same time. All these 3 steps happening or the dissolution process happening at the same time. So on the basis of under this or for clear understanding, and in step 1, separation of the solvent molecules, which only happen by overcoming the intermolecular force of interaction, because to break intermolecular forces energy is required, or we can say that, as we have discussed, number 1 point is the disruption of the molecular bond. So in step 1, disruption of the solvent molecular bonds happening within the step 1. Or in the similar way, in step 2, separation of the solute molecules occur by the energy absorption, again by the energy absorption or disruption in the molecular bond of the solute molecule by the energy absorption. In step 3, or overall we can say that step 1 and 2 requires energy, but in step 3, formation of the bond between the solute and solvent molecule causing the release of energy. Step 1, separation of solvent molecule is happening. In step 2, separation of the solute molecule is happening, but in step 3, mixing of the solute and solvent molecule happen within the system. Energetically, we can say that step 1 and 2 requires the energy input, which is endothermic in nature, to break the attractive intermolecular forces among the molecules of solute or among the molecules of solvent. So energy is required. So step 1 and 2 are basically endothermic nature, but step 3 may be exo or endothermic. Here we are considering 2 different cases. If solute solvent attraction is stronger than solvent or the solute attraction, so solution process is favorable and exothermic in nature. If solute solvent interaction is more stronger, or the attractive intermolecular forces between the solute and solvent is greater than the solvent molecules or among the solute molecules, so the solution process is favorable, because the interaction between solute or solvent is much more greater as compared to the solvent interactions or the solute interactions. So the overall process is dissolution process is favorable and exothermic in nature. So in that case, delta H should be less than 0, or we can say that delta H will be negative. But in case 2, if solute solvent attraction is weaker than solvent or the solute attraction, so the solution process is endothermic in nature. If the force of attraction among the molecules of solvent or among the molecules of solute is greater as compared to the force of interaction between the solute solvent molecules. So the whole process or the step 3 is endothermic in nature. So on the basis of this, we can consider that the overall dissolution process may be the endo or the exo, purely depending on the step 3. In this slide, we are clearly mentioning that how enthalpy change happen graphically. We consider these two graphical representation for the exothermic or the endothermic solution process or the solution formation. On y-axis here we are mentioning the enthalpy, or on x-axis is the overall solution process. Here in A, which is exothermic solution formation, you can clearly observe that solvent molecules or the solute molecule possess little bit energy on the enthalpy graph. When they are get separated, they acquire some energy for their separation of the molecules. So as we have mentioned that the separation of solute or the solvent molecule is endothermic in nature, but after mixing of solute and solvent, the force of interaction between the solute and solvent molecule energetically is stronger as compared to the solute or among the solvent molecules. So we can say that solution process is exothermic in nature, or enthalpy change should be less than 0 or negative, because the force of interaction among the solute or solvent molecules is stronger, which causing the more change in enthalpy as compared to the molecules of the solvent or the solute. So you can observe that the overall enthalpy of solution process is depending on step 3. But in caption B, which is the endothermic solution formation, here you can observe that solute and solvent molecules are of at lower energy enthalpy graph, while when they are got separated, they require energy understood for weakening the intermolecular force of interaction. They require energy, and after their mixing, because the solution process is not so favorable, or the interaction between the molecules of solute and solvent is weaker, due to this weak force of interaction, the energy change is not so much as compared to the energy absorption which happening in step 1 or 2. So we can say that delta should be greater than 0, or overall dissolution process is endothermic in nature. You can also visualize the solution process for NaCl, which is only mentioning in step 1 or 2. In step 1 you can observe that lattice energy, or the energy which is required for the separation of the ionic substances, or in step 2 is the hydration or hydration layer formation around the ionic species. So the step 1 or step 2, you can clearly observe that there is difference in sign. First one is endothermic in nature, second one is the exothermic in nature, because the bond formation is happening in step 2, but in overall dissolution enthalpy is positive or endothermic in nature. This is the overall lecture about the solution process or the dissolution process or the molecular view of a solution process.